Now that we've taken apart a TCP segment, let's look at a UDP datagram. Now, UDP is not like TCP because there's a lot of differences. They both take place at the transport layer, of course, but their construction is a lot different. First of all, a UDP datagram is very much smaller than a TCP segment is. And it does not have all the extensive header fields that TCP has. It only has four, in fact, four header fields, and two of those you don't even have to use. They're optional. Now, the reason it doesn't have all these extensive header info that TCP does is because it doesn't carry out a lot of the same processes that TCP does. It doesn't have mechanisms to guarantee reliable delivery, error connection, flow control, windowing, and so forth. It doesn't need to, because basically it's used for protocols that don't require all that overhead. It's used for protocols that require real-time delivery and certain broadcast protocols. Things like DNS, for example, DNS queries and responses, DHCP, getting an IP address, Trivial File Transfer Protocol, or TFTP, and of course voice over IP. Any kind of thing that streaming media, streaming music, all use UDP because you really don't want that correction mechanism to keep interrupting the flow of the streaming media or whatever. You don't want a choppy sound that's coming to your computer if you're listening to music, for example, and you don't want to keep hearing the same little bit of music over and over again because it's trying to correct because it dropped a packet. UDP basically is very small and lightweight. An advantage actually over TCP is that it will drop data and not try to go back and correct it, rather delaying it. And that can be very helpful when, again, you're delivering stream media or other broadcast types of protocols. Now let's go ahead and look at a simple diagram of a UDP datagram. And again, it only has four fields, and two of those again are not required. The source port and the checksum are really not required. Now you have bit offset 0, of course, and bits 0 through 15 are the source port. Okay, that's a 16-bit field, and then you have a 16-bit field for the destination port. And then you have a 32-bit length field and a checksum field. Then you have the UDP data itself. So this is actually very simple. It's a very lightweight protocol. It's a very simple protocol. And it's actually a lot faster than TCP because it doesn't have all that overhead it has to do. In the next session, we're going to look at a quick demonstration of some UDP traffic so we can actually show you how this maps up to the UDP diagram that we're showing here.